Hi everyone, I'm Jackie Sakin, and today we're going to dive into the workings of the vehicle charging system and explain how it functions in three different conditions. When the ignition is on but the engine is off, when the engine is running at low or medium speed, and finally when the engine is running at high speed. We'll cover the role of the alternator, including its key parts, the rotor, stator, and rectifier, along with the regulator, fusible links, and how they all come together to keep your vehicle's battery charged and electrical systems running smoothly. First and foremost, I will explain what is a charging system. So, a charging system converts electrical energy into mechanical energy to recharge a battery and power electrical components in vehicles or machinery. Before we get into the details, let's briefly go over the major components of the charging system. First component is alternator. This converts mechanical energy from the engine into electrical energy to charge the battery and power the vehicle's electrical systems. Inside the alternator, the rotor spins and interacts with the stator to produce electricity. Next is rectifier. This converts the alternating current produced by the alternator into direct current needed by the vehicle's electrical systems and battery. Next is rotor. This is a rotating magnet inside an alternator that creates a magnetic field as it spins, essential for generating electricity in the stator. So stator, the stationary part of the alternator that surrounds the rotor. As the rotor spins, it induces an electrical current in the stator's coils. Next is voltage regulator. This controls the output of the alternator to prevent overcharging or undercharging the battery. Next is fusible link. Acts as a protection device for the electrical system. It prevents excessive current from damaging components. Next component is battery. Stores electrical energy and provides it when needed. Lastly is charge warning lamp. This signals when there is a problem with the charging system. Now that we know the key components, let's see how they work in different operating conditions. This is the condition 1. In this first condition, the engine is off but the ignition is on. Two circuits are active here. Power flows from the battery to the fusible link through the ignition switch and into the IG terminal of the regulator. It continues through the PL1 and PL0, which are engaged in this condition, and flows to the F terminal of the alternator. This current energizes the rotor coil in the alternator, creating a magnetic field that's necessary for generating electricity when the engine starts. Another path leads from the battery to the charge warning lamp, then to L terminal of the regulator and to P0, which is engaged with P1. From there, the current flows to ground, which turns on the charge warning lamp on the dashboard, indicating that the alternator is not charging since the engine is not running. At this point, the charge warning lamp is illuminated and the rotor is magnetized, ready to generate power when the engine starts. For the second condition, the engine running at low or medium speed. So when the engine is running at low or medium speed, the alternator begins generating electricity. Now three circuits are working. For circuit 1, the stator coil in the alternator generates electricity due to the spinning rotor. The current flows to the N terminal of the alternator through the voltage relay in the regulator and down to the ground. As a result, the voltage relay becomes an electromagnet which engages P0 with P2, allowing electricity to flow through this new path. Observe that current flows to the voltage relay, which makes the voltage relay generates electromagnetic force. This causes the P0 to engage or pull down to P2. Another circuit is from the another side of the stator coil and flows to the rectifier, then flows to the B terminal of the alternator, to the B terminal of the regulator, and to the P2 and meets with the connection from the battery. This connection then travels to the voltage regulator to the A terminal of the regulator and ends to the ground. In this condition, the current is moderately strong. That is why the voltage regulator creates electromagnetic force that causes the PL0 to be pulled down and disengage with PL1. Now for the circuit 3. If the battery's voltage is lower than the alternator's output, the current flows from the alternator's B terminal to the battery, charging it. Additionally, current also flows through the resistor and back to the F terminal of the alternator, which helps regulate the alternator's output. At low or medium speed, the charging system balances the flow of electricity, keeps the battery charged, and ensures all electrical components have sufficient power. Now let's move on to the third condition when the engine is running at medium or high speed. In this state, the alternator produces more power and the regulator plays an important role in preventing overcharging. For circuit 1, the stator coil generates a higher voltage due to the increased engine speed. The current flows from the N terminal of the alternator to the N terminal of the regulator through the voltage relay and to ground. The voltage relay becomes a strong electromagnet, pulling P0 to engage with P2, as seen in the second condition. For circuit 2, high voltage from the stator coil flows to the B terminal where it passes through P2 and P0 to the voltage regulator and down to ground. The voltage regulator ensures that the alternator does not produce too much current by controlling the flow to the rotor coil. Lastly, another connection from B terminal of the alternator flows up to the ignition switch, which is connected to the fuse and flows down to the IG terminal of the regulator and passes through a resistor and turns right to the PL0 and PL2 and avoids the flows to the alternator. It turned right to PL0 and PL2 down to the E terminal of the regulator and ends with the ground. To summarize, the vehicle's charging system adapts to different engine speeds, regulating the flow of electricity to keep your battery charged and your electrical systems powered. Whether your engine is off, running at low speeds, or operating at high speeds, the alternator and regulator work together to ensure everything runs smoothly. Thanks for watching, and I hope this explanation helps you understand how the charging system works in your vehicle. Bye everyone!